Good evening and happy holidays. Today is the 20th of December, and we have a lot to talk about this evening. Firstly, we have a storm system that's impacting the region right now. You can see how high these cloud tops are based off of the scale right here. Basically, satellites measure how high the cloud tops are by their heat emission, and they can construct an image. And basically, where you see 100, that actually means negative 100, and that indicates colder cloud tops, higher up cloud tops, higher in altitude, and those indicate stronger thunderstorms. And yes, we're actually going to be talking about thunderstorms in late December, and we'll get to that in a little bit. But looking at the system, you can see the overall evolution of it. This was around 2 p.m. You can see the large expanse of high cloud tops to the west. As we roll forward, you can see the western edge of the precipitation and the higher cloud tops is approaching very quickly. And you can see also the center of the low pressure spinning a little bit. We can see the low pressure a little bit better if we look at this. You can see here's 983 right by Chicago, and then it gradually weakens a little bit as it heads up to Michigan. We can also see this. Here's a surface map as it heads up to Michigan. Here is the 500 millibar heights and vorticity. Basically, this is a measurement of vorticity is a measurement of turning in the atmosphere. Basically, where you see wherever you see color is basically where there's counterclockwise turning, which indicates an area of low pressure. If there were to be gray, then that would be the opposite, and you see clockwise turning, indicative of a high pressure system. Also, we have the radar image at the top left corner. You can see we have some precipitation into the Reading area and also into the Lancaster, Lebanon, and York areas. There is actually interesting reports coming from eastern Pennsylvania and south central Pennsylvania about actually some frozen precipitation mixing in to begin. And this actually makes sense because if you look at the radar image, you can see it's kind of having a hard time progressing to the east. And what that means is that there could be some lower level drier air, and that could be evaporating the precipitation before it reaches the ground. And what that does is that in turn lowers the dew points, and you get more wet bulbing potential. And basically, when we talk about wet bulbing potential, that means that there's a greater potential for temperatures to fall while precipitation is falling. As you know, basically when precipitation falls, it cools the surface. That's called evaporative cooling. And the dew point is the temperature at which the lowest temperature at which the temperature could be at saturation. So the dew point is basically the wet bulb temperature is the temperature currently to the dew point temperature. So there could be some cooling going on as precipitation falls is what is going on here in Pennsylvania into actually portions of New Jersey. As I mentioned earlier, there is the potential for some thunderstorms to impact the mid-Atlantic into the northeastern area. And here what we're looking at is that we're looking at a simulated radar image from the 18Z NAM, and we can see that the overall evolution of the storm. Here we can see the storm, the spin of the storm right here. We can see the trailing front right here. Take a look at what's going on right here, though. That is actually a squall line that has been consistently developed on the NAM. And what that would do is that it combined with some pretty strong severe weather parameters that could actually have gusts to the 40-50 mile per hour range, especially if you get closer to the coast. Inversion doesn't really seem to be a problem. And what happens with inversions is that inversions tend to what inversions are is that they're areas in the atmosphere where temperature rises instead of cools, and as you go up in the atmosphere, the temperature generally decreases because there's less radiation from the ground reaching those altitudes. So um, an inversion basically prevents any stronger winds from mixing down to the surface. There's none of that. That means that some stronger winds aloft can mix down to the surface and provide some strong wind gusts. So let's look at the future. The future looks interesting actually for the area. Let's start off at hour 63 on the 18Z GFS. And here what we're looking at is we're looking at surface temperatures in degrees Celsius. So this 0 line would be the 32 degree Fahrenheit line. Let's go to hour 99. This would be on Christmas Eve, and this would be at around 1 p.m. So here we see the 32 degree line is just northwest of I-95. Well, actually, it's considerably northwest of I-95 in the Philadelphia area, just south of the I-78 corridor in New Jersey. As we advance, we go to, this would be at about 10 p.m. on Christmas Eve. You can see precipitation has moved in. Precipitation is about to move in on this previous frame, and this would be at about 7 p.m. This is when about Christmas Eve is taking place, and you can see that the freezing line is just northwest of I-95 between, say, Trenton and New York City, and considerably northwest of I-95 around the Philadelphia area. As we go to hour 111, we can see that there is still snow in the area around Christmas Eve. Actually, now this is around 3 in the morning on Tuesday, and you can see that the freezing line is now southeast of I-95. Still snowing. As we continue, we can see that at hour, let's say 1:17, the precipitation is already out of here. So this would be at around 10 in the morning. So on the GFS, this system looks to be coming on around maybe a little after 7 p.m. on Christmas Eve, and then it's out of here by 10 a.m. on Christmas Day. So it's not a long duration event, and it doesn't look like it's a really big deal other than a nuisance, but it could be nice to see some a white Christmas for some. And typically, and sometimes these smaller events tend to overperform, and there's quite a few examples of that in the past. The Canadian also has this little event on Christmas Eve. If we go to hour 102, you can see here it is in the Midwestern areas. 1,004 millibars. You can see it's not really a strong system at all. As we advance to 108, you can see it goes down a little bit, but not that much. And as we go to 114, you can see there's some mixing going on in southern New Jersey. As we advance to 120, you can see that I-95 is basically the mix line, and places just to the north are getting snow, and just to the south are getting rain. You can see that scoots out of here, but look what's happening right here. We have another system that's developing in the southern states, and this could actually be potentially be a significant impact, weather system to reach our area. And as we progress on the Canadian at hour 144, you can see 996. This is already considerably lower than the Christmas Eve wave event, and that indicates that it's stronger. Lower pressure indicates a stronger system overall. As we head to hour 156, you can see that there is a large swath of snow. And look what's happening right here. We have what's called a transfer. And what that is that you have an area of low pressure ride up inland and then transfer basically to the coast. So it transfers kind of like the dominance from the Midwest to the East Coast. And the reason for that is because we have a lot of blocking up here. And note what we also have up here. This is what we call our 50-50 low. That is what we need for a big event along the coast. So you can see here's a considerable amount of snow. And by the time we get to hour 168, it's still snowing a lot. And the system has pretty much completely transferred down to 993 millibars. And it's snowing basically around maybe, I would say just about 5 miles southeast of Philly, northwest. By hour 180, it's out of here. The GFS also generally has this idea, although it's a bit further south and east. You can see here at hour, what is this? Hour 159. You can see, let's go back a little bit. Hour 153, we have a major snowstorm for the mid-Atlantic on the 18Z GFS. You can see temperatures are plenty cold enough to support frozen precipitation. And we have, as we advance, what happens is that, and we can see this better at 500 millibars, basically the trough that is associated with this storm did not tilt to the right or tilt negatively in time to bring this up the coast. So therefore, look what happens. It slides out to sea. The GFS has been very inconsistent with this storm, and this is not indicative of any trend whatsoever. The European is still inland and gives the area a rainstorm, and the reason being is that it doesn't transfer to the coast, and so therefore it doesn't funnel in any cold air. And there's a bunch of reasons why the European has a rainstorm. One of them being the European doesn't have a 50-50 low like the GFS and the Canadian have, so therefore it's much, much warmer. Also, I believe the confluence, which is basically an area of energy, to the north of the system is aligned differently on the European than it is on the GFS and the Canadian. So we have a lot to talk about. The JMA also has a system. You can see widespread. This will be a quarter of an. This line right here will be about a 3/4 of an inch, and this line right here will be about an inch. These yellowish lines are isobars. They represent areas of constant pressure, and right here we have the center of the low pressure system. So there you have it. This definitely looks to be an interesting week or two up ahead of us. So please continue to tune back in for more updates for the latest information on these systems that are ahead of us. And I hope that you have a very nice holiday season.